Hello, everybody. Yeah, the last slot is always something special to get. So thank you all for coming to my session. Today's session I'm giving is about a mocking framework uniquely for Kotlin, namely MockK. Just to shortly introduce myself, my name is Yannick De Turck. I'm a senior Java consultant and practice manager at the JWorks unit of Ordina, Belgium. So our unit is about Java development and JavaScript development. I'm on Twitter and GitHub. If you have any questions or remarks about the session, feel free to ping me. And we also have a blog post on which we often post about new frameworks and technologies that we stumble upon, so feel free to have a look at that. So I'd like to start the session with a couple of questions first. So the first question I'm asking you guys is, who is actually here writing unit tests? I hope everybody does. Is there anybody who isn't writing unit tests? If so, shame on you. Who here actually uses Kotlin? Also using it in production? Okay, about half of the people. Anybody here who has heard about MockK? Okay, that's good. A couple of people. Is anybody actually using MockK? Okay. So in this session, it will be mainly about an introduction to MockK and just showcase the features and the things that it has to offer to you. So it's not really too advanced, but more introductory. I'd like to start with a small story. So I'm mainly a Java developer, and for all my unit tests, I've always been using Mockito. I'm a huge fan of Mockito, so it's my go-to framework for using mocking in my Java unit tests. So I'm a big fan of that. I think that everybody here develops in Java, right? So I assume that most people know Mockito as well. Just to give a small example of a Mockito unit test, so it's pretty simple. You define your mocks on top, and in the setup, you create all things necessary for your test class. And when writing your test, you have this part where you just set up your mocks. You have the part where you actually invoke the code that you'd like to test, and then at the end you specify all the verify statements and the assert statements to see if the result actually is as expected. So, and then I think it was somewhere between March 2017 and November 2017, I stumbled upon Kotlin, which was still fairly new then. Version 1 was released a bit earlier before that, but in between version 1.1 and 1.2, I stumbled upon it, and it really caught my attention. And I wanted to do something with it. And somewhere around early 2018, I wanted to get my hands dirty on Kotlin because it really looked very promising to me. And yeah, to start off, I wanted to write a blog post on how mocking works in Kotlin. So I was like, okay, Java and Mockito work like a dream. Would it also be the same with Kotlin? So that was my main question that I was having. So I set up a small project. I added the Mockito dependency to my project. And then I just wrote a couple of classes. It's pretty simple. I have this generator class that generates a random string. Well, in my case, it's always the same string. And then we have a DAO class that just inserts a record into a database, let's say. In my case, it just prints a statement. And then we have a basic service right here that takes in a generator and a DAO instance. And yeah, the service calculates something, it will generate a record and it will just insert the record into the database for our calculation. And then I just wrote my my unit test with Mockito. So I just did it the same way as I usually do in Java. And yeah, if you got your hands dirty with Kotlin and you use Mockito, yeah, it already feels a bit special that you have to point to the Java class right here. And yeah, as you can see in Kotlin, maybe you haven't picked up on that yet, but you can actually write sentences for your tests if you put them between backticks. So that's something useful. And yeah, something that you see here, the when you have to put the when method in backticks because in Kotlin when is actually an expression. So that's already something quirky. But yeah, for all the rest, it was just basically the same as in Java. And then, as I wanted to execute my test and to see if everything works as expected, yeah, I just stumbled upon this nasty exception. And I was like, what? What's going on? So yeah, okay, what was I supposed to do right now? And as I looked a bit deeper into Kotlin, I learned that all classes and functions are final by default in Kotlin. And yeah, that's somewhat problematic with Mockito because the way that Mockito creates its mocks is by relying on subclassing. And yeah, if you have a final method or a final class, that can be a bit tricky. So you might ask yourself then, okay, so what are our options then to use Mockito with Kotlin? Should we add an open to everything, open to all our classes, to all our methods, or should we maybe just define an interface for everything? I know that in Java it's very, it's something that you usually do, but in Kotlin that becomes less the case. And yeah, I felt a bit sad about that. So I did some research on the wiki of Mockito and I stumbled upon this part. And so basically up until Mockito version 1, it wasn't possible to mock a final class or a final method. And starting from Mockito 2.1, they added in an incubating opt-in feature that allows you to subclass, to mock final classes and methods. And yeah, basically the thing that the article says here is add a certain file with a certain content in a certain location for it to work. And yeah, okay, after doing so, you are able to properly create mocks of all these classes and methods in Kotlin. And yeah, just working with that specific file with a certain content and having to put it in a certain location feels a bit hacky. Now, they did promise that a programmatic way of using this feature would be foreseen a bit later on, but as far as I know, they haven't caught up with that. So yeah, it's still something special to do. And then as I did as I did some more research, I stumbled upon this MockK framework. Besides the pretty colors, it seemed like a really cool framework to delve a bit deeper into. There's actually one single guy behind this framework, and he's called Oleksiy Pylypenko. I hope I pronounce his name correctly. And yeah, so he's the sole guy that has been building this framework and is still actively developing it. There are a lot of new things that he keeps on adding to MockK. And I've also given this session last year in December at Devoxx Morocco. And in between now and then, he still kept on adding new features, so I had to keep on updating my presentation. Now, MockK's main philosophy is, of course, to start off with offering first-class support for Kotlin features. It's a library specifically made for Kotlin. And with MockK, they want to offer a pure Kotlin mocking DSL for writing clean and idiomatic code as you're used to, as you're working with Kotlin. Shouldn't feel any Java-ish, should feel clean and pleasant to use like it is, yeah, just programming in Kotlin. And of course, to provide mocking support for final classes and methods. Otherwise, we would be in the same case as with Mockito. So, mocking final classes and functions. So, contrary to Mockito, that depends on subclassing. MockK actually builds proxies for these mocked classes and methods. And you basically have the code of existing methods that gets transformed. It includes calls to the mocking library. And yeah, a side effect of this is that there is a small trade-off to performance, but it shouldn't be anything groundbreaking. So without further ado, I added the dependency to my project. And I created a new class in Kotlin to do some testing with. And the class I have here is basically the car class with a simple function drive. And we can specify a direction, which is just an enum with the 4 directions that you can drive in. And then a speed, which is a long value with a default value of 30. And the method returns a string. So basically what the method does, it just prints out which direction you're driving at which speed. So about the syntax. Syntax is a bit similar to all mocking frameworks. In the first part, you have to define your mock. You can do it like this. In a couple of slides, I will also show an example with annotations. So it's really simple. Huh? You just define a val of your mock car, and you just create it with this mock statement. There's also no need to point to the Java class or anything. It's just simple as that. And then we have to stop our calls. And you see that it somewhat reads like a sentence. Every car.drive with in the direction north call should return this string. So that's the same thing that we have with the Mockito when statement. Then you execute the code that you want to test. So we let our car drive in this direction. And then we have our verify block. And here it's also a bit the same like with the stubbing part. So you basically just verify whether the car drove in the north direction. And that's it basically. If you would throw this in a test, it would look like this. So every car driving north should return this string. We execute our code, and then we verify whether the car has actually driven north. Now, in Kotlin, there is something called strict mocking, and this is something interesting. By default, all mocks in Kotlin are strict, so you need to define some behavior to your mock. What this means is if you have this example, so in this case, we commented out the stubbing part right here, and we just immediately called this method of our mock. And yeah, if you were to execute this test, you would run into this error. And here MockK is saying that it hasn't found an answer for this drive call that we called right here. And yeah, so by default, MockK wants you to provide to mock your calls by default. Now there is also something called a relaxed mock that you can specify when you define your mock. So you can actually pass on this relaxed parameter to relax your mock, to become a relaxed mock, all zen and stuff. And what then happens is that MockK will provide a dummy stop for you. So by doing so, you don't have to stop all these calls yourself. Now, the tip that I would give you is just to stick to strict mocking and to do all the mocking yourself, because it will give you nicer and easier to read tests that are nicer and easier to read. Having code and tests that are easy to comprehend and to read is something that I find very important. So that's why I'm just giving this tip. You might say, okay, so we can mock classes. Can we also do the same with objects? And yeah, of course you can. So imagine that we have this object math, and there is a single function that adds two integers. It returns the sum of these two integers. And with MockK, you can do the same thing as you can with a class. It's just slightly different. So you just call this mock object class and you pass on this object. And something interesting to see is that as long as you don't mock a specific call with a specific input, the usage of this object will return the result as expected. So if we were to specify this assert statement here, it would work as intended, as we would expect. But if we were to mock a call, so let's imagine that, okay, we say that adding 1 to 2 doesn't equal 3, but it equals 4. If we specify an assert statement after after stubbing that call, it will actually pass. So yeah, it gives you control on how you mock the objects, because it's perfectly normal that you don't always want to mock these calls, but only in a certain phase of your tests. There is also something called hierarchical mocking, and that's something that's only been added recently. And it's a way to give you control over mixing mocks and real objects. So let's imagine that we have this address book interface, and it holds a value for a list of contacts. A contact has a name, a telephone number, and an address. And the name and the telephone are both strings, whereas the address is of the type address. And address looks something like this. So basically it holds a city and a zip code. Now, if we want to mock an address book, we would do it like this. So we commence by specifying the mock method here on our address book. And then we say that, okay, whenever contacts is being called, we should return a list of objects. So our first object that we want to return is another mock. So now we're specifying mocks inside of mocks. And you see here that, okay, every time that name, telephone, and address, the zip and the city and the zip code of an address is called, we return all these values. And you see here that here we have something that's being called chain calls. So instead of first returning an object of address, we can just directly return the city and the zip of our address object here. You can also do it more in the classical way, that you specify the address first and then the city and the zip code. But yeah, you can just pick one of the two that has your preference. In Mockito, we also have something called spies, and we also have that in MockK. So a spy is also for mixing mocks and objects. So imagine if you have the class that you're testing that also has a certain method, and okay, the class that you test, you usually don't mock that, but you want to mock that specific method just to try a specific scenario. That is something that you can do with a spy, or with a spy you can also set up your test to verify whether certain calls inside your test class. So creating a spy is very similar to the creation of mocks. You just use this spy_k method right here, and then you pass your instance right here. We let our car drive north, and then we can also just verify whether the car has been driven north. Is this clear about the spy part? Yeah. Okay. So we've been doing it all in code right now, the creation of mocks of spies, but you see that there are also a various amount of annotations that are available. If you want to use these annotations, you do have to be aware that you have to utilize this late init prefix here of your variable. But that's basically it. For the rest, it should feel a bit the same as it does with Mockito. In Mockito, you usually use annotations, at least I do. So if we were to look at the verify method, just a bit deeper in detail. So with verify, we can check whether a certain call has happened. So we've seen a couple of one of these. So if a car has been driven in a certain direction, I will come back to this any parameter that you see right here. So you can specify specific values, but you can also specify a range or values or any other special combination. But more on that in a couple of slides. Then we can also verify whether calls have been made for a certain amount of times. For example, if you want to verify that we have at least one call being made, we can specify this at least parameter here. You can also specify a maximum amount of calls that may happen, like here with the at most parameter. There's also a way to do an exact check, so only 2 calls may have happened. If 1 call or 3 calls were made, yeah, okay, your test will just fail. You can also work with timeouts. Yeah, depends on if the method that you're calling is something that can take a lot of time. You can just combine it with this timeout parameter right here. There's also a concept called group verifications. So imagine that we have our car driving north and east. We can group them inside a single verify block where we just verify both calls here instead of always having to specify the verify part multiple times. If you're verifying a lot of calls, this makes it a bit cleaner. So, and if we execute this test right here, it would pass just fine because the 2 calls that we are verifying right here have actually been called right here. There is also, it's a question? The order. In this case, the order doesn't matter, but it will soon. It will soon matter. So let's imagine that we drive north, then east, and then south. We can, besides just verifying whether the calls have been made, we can also verify the order. So in this case, we are verifying 2 calls right here. So we are verifying whether we first drove south and then we drove north. Yeah, okay, obviously this isn't gonna pass, so this will fail because we first driven north and then we driven south. And okay, you might also remark, yeah, okay, what about this direction east that we have been driven? Doesn't that matter? In this case, it doesn't, because by default, Mockito doesn't, MockK doesn't force you to verify all the calls. But yeah, if we were to rearrange the order so that we first drove north and then south, yeah, in this case, test will pass. So that's a good thing. And then we have a third option with the verify block. So we're back to driving north, east, and then south. So in this case, we can verify the sequence, whether the sequence has actually happened. So first we drove north, east, and then south. And in this case, the sequence is good. But let's imagine that we leave out one of the 2. For example, here we left out the east part, and now we're verifying the sequence. And yeah, the verify sequence verifier block will check whether all these three calls were made. And yeah, in this case, it won't pass. And yeah, in Mockito, you have something called verify no more interactions that you can call. You can pass a list of mocks, and all the mocks that were passed will be checked on whether all the calls that were made to these mocks were actually called. And this was something that was missing in MockK for quite some time, but that was also recently added, so that's a really good thing. So here we have a mock of a cat, and then the cat can make a sound. It just returns meow. Let's say we call this method right here, and then you see here at the bottom that we'd like to confirm whether all calls were verified on this cat. And this verify statement here is commented out. And thanks to this line here, the test will fail. If you would leave out this part, yeah, it wouldn't matter. So this is something that that I was pretty happy about to see that I added this to MockK. And yeah, as I said, it's very similar to the verify no more interactions in Mockito. So what else do we have? Yeah, if you want to exclude less significant calls when confirming these verifications, there is an option to do so. You just have to specify this line of code here so that we can exclude all these make sound calls so that we don't check them. So in that case, the previous example would pass just fine. So mature expressions. So in the verify block, you might have noticed that EQ part, that equals part. So these are actually, you can actually pass a lot of matchers to verify whether your argument has it falls between a certain range or if it fulfills a certain predicate, and there are a lot of them. I'm not going to run through all of them, but you can specify ranges, you can specify regexes. The table is actually pretty long. I just took a couple of interesting ones. You can check whether a value is more or less than a certain number. You can use an AND or an OR logical check. So there are a lot of them, and you can bind them as you see fit. So this is, oops, sorry. So here you see that, yeah, the direction we're checking for the direction east and west, so it can be either of the two. And here we see the range, yeah, a range for the speed, so it should be between 10 and 50, and it's inclusive on both values. Now for capturing arguments, I have to speed up a little bit because I'm shortly running out of time. So in Mockito, you have argument captures. This is also something that you have in MockK, but here they are called slots. And yeah, as you set up your calls, you can capture a certain slot, and then at the end, you can retrieve the captured value. You can also do this with multiple values, but instead of using a slot, you have to use this mutable list right here, and then you can capture the list and you can check all the values that have been captured. That's really interesting with spies, for example. Constructors can also be mocked. You have this mock constructor method right here that you can pass a certain clause, and then every time that a new instance is created, yeah, it will be mocked. And then you can also just mock the responses, and you can verify whether certain calls have been made. Private function mocking. Yeah, so private functions, you normally don't have access to them. So in order to mock them, here we have the drive method with a private function accelerate. And yeah, let's say we want to test whether the private method was called. So yeah, to do this, you have to specify it like this. So between these square brackets, you can specify the method of the private function to mock this. And in the verify statement, it's pretty similar with the same way to do this. What else do we have? Yeah, you can also do this for properties. I'm going to skip this part because there is also coroutines. Yeah, for mocking coroutines, you have to add this extra dependency. Do we have a couple more minutes? Okay, perfect. Okay, so we're almost done. Just bear with me for a few more minutes. So for coroutines mocking, we have to add this additional dependency in order to mock these. So it's a dependency from JetBrains, so it's not something fishy or anything. And then you have the usual functions that you have for mocking these mocks, but you just have to use the co prefix with them. So for creating the mock, it's very similar, but let's imagine that that our car drive method now uses coroutines. Well, we just have to prefix the every with co, so co every, and we would have to do the same thing with the verify statement right here. So something that I also like about MockK is the clear and informative error messages. So let's imagine we have this call. So we've mocked the east direction, and we verify the east direction here. Yeah, I think this is a small error in my slide, but let's imagine that you mocked the wrong method, then you would get an error like this, no answer found for this call. So it's really easy to comprehend. You don't get any nasty null pointers exceptions like you do with Mockito. This is also another example. So this is an example where we are verifying whether a certain amount of calls were made. So there were 3 calls, but we only matched 2 of them. So that also gives you enough information to quickly resolve that. And this is also a similar example. Here we expected only 2 calls, but we actually found 3 of them. So if we were to compare both test samples from Mockito and MockK, so yeah, the Mockito one looks okay, but it could be better. If you put a MockK next to it, it just feels, yeah, it just looks a lot more pleasant to read, and it just feels more Kotlinish. So I'm a fan of that one. And just to end the talk, I want to give my own personal experiences about the MockK framework. So it looks a very promising library to me. It's very pleasant to use, and it really suits the Kotlin language. The author is also very approachable on Gitter and GitHub. So if you stumble upon an issue, you can just visit Gitter, and yeah, he's on Gitter a lot of the time, so shouldn't take long for you to get a response. So after his presentation, who here who hasn't used MockK is going to try it out in his Kotlin project? Okay, a couple of people, that's cool. It's mean that I've did something good today. So just to end up, a couple of resources that I want to give you guys. So you have the MockK website right here, which has a lot of documentation, and I mean really a lot. It's really well documented. There's also a series of blog posts right here, written by the author himself, about how you have to use MockK. I've also written a blog post right here. It's on the tag blog that I've linked in my first slide. I will also share these slides after the session with you guys. I'll just tweet about them, so you can just look it up. There is also an interesting session that was presented on KotlinConf 2018 about best practices for unit testing in Kotlin, given by Philip Hauer, that you should have a look at. And last but not least, for combining MockK with Spring, there is a specific library for that you can use in your project. So that's all. I've run a bit over my time, but if you have any questions, feel free to approach me and ask them. Thank you.